students, welcome to BYJU'S Classes. This is Nidhi and I welcome you all to the discussion of JEE Mains 2021 paper which was held on 25th Feb morning shift. Well, this question is from limit and guys, it is not an easy question, let me tell you very frankly. I would put this question from moderate to difficulty level. Let's see the question, what the question is saying. Limit n is approaching to infinity. 1 plus, I have one term over here which is 1 plus 1 by 2 till 1 by n summation divided by n square whole raised to n. Right? Okay, so I have to find this value. Now, how can I solve this? Well, if I look at the term which is given, one thing pops in my mind is it might be similar to 1 raised to infinity form. For that, obviously, this term should approach towards 0, which is correct. Why? Because I have 1 plus 1 by 2 till 1 by n. The terms definitely will be smaller as compared to the denominator part, which is n square approaching towards infinity. So this definitely will have limiting value as 0, right? Okay, so definitely it is 1 raised to infinity form. Now comes the question, how do we solve this 1 raised to infinity form? Well, the formula is, it can be written as e raised to limit n is approaching to infinity. If I take the base as fx, then it's fx minus 1 multiplied by the power, which is gx. So it's going to become 1 plus 1 by 2 till 1 by n divided by n square minus 1 multiplied by n, right? So this 1 got cancelled and 1 n is also getting cancelled. So we are left with e raised to limit n is approaching to infinity and this entire term. Now, if I try to apply the same concept, what happens here is I cannot say truthfully that this term is approximately a very less quantity because the summation is actually going towards infinity, right? N is approaching towards infinity, that means 1 by n will approach towards 0. So to find this limiting value, what am I going to do? Well, obviously in numerator I have summation of HP. For that I don't have any formula. So I'll apply some another trick over here. Quickly see what can we do. I'm taking the numerator as S. I'm writing S as 1 plus 1 by 2 plus 1 by 3 till 1 by n. Clear? Now, listen very carefully. What am I going to do? We already know that n is a really large number, right? It's approaching towards infinity. So I'll break this n in some smaller groups. The first one is actually 1. The second one is 1 by 2 plus 1 by 3. The third one will become 1 by 4 plus 1 by 5 till 1 by 7. The fourth one will be 1 by 8 plus 1 by 9 till 1 by 15 and so on they are going. So every group is starting by 1 by 2 raised to something. 1 by 2 raised to 1. In this case, here it's 1 by 2 square. Here it's 1 by 2 cube. Next one will be 1 by 2 raised to 4 and so on and so forth. Clear? This is going on till infinity. Okay, so now what we are going to do, I can say that my S here is 1 plus. This second term, which is 1 by 2 plus 1 by 3, will be slightly less than 1 by 2 plus 1 by 2, isn't it? So I'll get S less than this part. Similarly, my third bracket or the third group will be less than 1 by 4 plus 1 by 4 till 4 times. Then I have the fourth one as 1 by 8 plus 1 by 8 plus 1 by 8 till 8 times and so on and so forth. So I can say that lastly I might get something like this. I'll have the last one as 1 by 2 raised to p plus 1 by 2 raised to p plus 1 by 2 raised to p till 2 raised to p times. Isn't it? Okay, so the entire S will become less than, my every group is becoming 1. My first is 1, my second is 1, my third is 1. So this one I have to add how many times? P plus 1 times, right? So I can say that my S will be definitely slightly less than P plus 1. Again, P is approaching towards infinity. So therefore, I can finally conclude that if I want to find this L can be written as E. Now I have to put limit on P approaching to infinity, and it's going to become P plus 1 because it's slightly less than P plus 1 divided by N, which is nothing but approximately 2 raised to P. And you know what is the limiting value of this term? P plus 1 divided by 2 raised to P. We know that denominator is really large as compared to the numerator. So it's going to be E raised to 0. So the final answer for L will also come equal to 1. This will become the limiting value of this question. Understood, guys? Perfect. So now if we look at the options, we can say that answer will be C. Well, the next question is from permutation and combination. The question says, what are the total number of positive integral solutions x comma y comma z such that x y z is equal to 24? So that means I have to find my x, y and z such that their product comes out as equal to 24. How do we solve this? Well, for this, we'll first try to factorize this 24, isn't it? So 24 is nothing but 8 into 3, isn't it? Okay, so this you already know that xyz can be written as 2 cube into 3 raised to 1. Now what? Well, now what do? We distribute the powers of 2 and 3 among three numbers x, y and z, right? So starting with 2 raised to 3, I have to distribute this part 3 among three numbers x, y and z. So here you can apply the beggars method if you want. In how many ways can we distribute 3 among 3 people, or let's say 3 variables x, y and z? So that is going to be 3 plus 3 minus 1 C3 minus 1 or 5 C2 ways. Similarly, if I have to distribute 3 raised to 1, that means this 1 among again 3 numbers x, y and z, I have to again apply the beggars method, and the formula, the value will be 1 plus 3 minus 1 C3 minus 1. That is nothing but 3 C2 ways. So the final answer will come out as 5C2 multiplied by 3C2, that is 10 multiplied by 3, that is equal to 30. So these are the total number of ways in which you can distribute power of 3 and power of 3 1 among numbers x, y and z, and these are going to give you the positive integral solutions possible. Clear? Okay, so now if we look at the options, we can clearly say that answer is going to be D. Well, the next question says, if a curve is passing through the origin and the slope of tangent to it at any point x comma y is given by this entire expression, then this curve also passes through the point. So if I have to check that which of the following point lie on the curve, I have to definitely find equation of curve. And for that, I have to solve this part. Now, what is the slope of tangent? Well, we can say that slope of tangent is nothing but dy by dx. That means this is a question of differential equation. They have given us a differential equation. We have to find a curve. So, I'll put this question in moderate to difficult level. You might find this question difficult, but if you actually listen to me and see how I will actually separate out the terms, I'll convert this question into linear differential equation. Yes, I'll do that. Let's see how we are going to proceed. So this is what they have given us the differential equation as. What am I going to do? I'll write dy by dx as it is equal to. If you look very carefully on right hand side, you have two terms. One is x square, another is minus 4x. Now guys, x square minus 4x comes in a perfect square. Which perfect square is that? X minus 2 whole square, that's correct. So I'll write one term as x minus 2 whole square. So that means from 8, 4 has already been taken. So left is y plus 4 divided by x minus 2. I'm separating this part. So this is going to be equal to x minus 2 plus y plus 4 upon x minus 2. Can you see a differential equation which is of the form linear differential equation type? No? Let's do one more thing. Substitution is required. X minus 2 is taken as t. Y plus 4 I am taking as u. When I do that, you already know that dy by dx will be equal to du by dt. So I can say that my du by dt further can be written as u by t plus t, or you can say that du by dt minus u by t is equal to t. Now can you see a linear differential equation written, guys? And I hope you know how to solve this linear differential equation. What do we find? Well, first we find is the integrating factor. So my integrating factor here will be e raised to integral of minus 1 by t dt, which is nothing but e raised to minus ln t, or 1 by t. So the solution will become u multiplied by the integrating factor, which is 1 by t, is equal to integral of t into 1 by t dt, which is equal to t plus c. And now when you substitute the values, it's going to become y plus 4 upon x minus 2 is equal to x minus 2 plus c. Now to get the value of c, what have they said? That this curve is passing through origin. So when I put x and y both as 0, it's going to become minus 2 is equal to minus 2 plus c. That means c is 0. Finally giving me the curve as y plus 4 is equal to x minus 2 whole square, a parabola, isn't it? And now, since I have to check that which of the following points lie on the curve, quickly substitute. So when I start with my option A is 4 comma 5. So when I put this, it's going to be 9 is equal to 4 minus 2 whole square. Definitely not correct. Then I have my B option, which is 5 comma 4. When I substitute, it's going to become 8 is equal to 5 minus 2 whole square, definitely not correct. Then I go to my C option, which is 4 comma 4. So when I substitute, I'm going to get 8 is equal to 4 minus 2 whole square. Again, not correct. When I put my D option, that is 5 comma 5, it's going to give me 9 is equal to 5 minus 2 whole square, which is definitely correct. That means my point 5 comma 5 will lie on the curve. So though you might find the question to be difficult, but now have you understood what we have done? We have separated it into x minus 2 whole square plus y plus 4, which was actually very important. After that, when we substituted x minus 2 as t and y plus 4 as u, we got linear differential equation. After that, I know very well you can solve the question in few minutes. Isn't it? Perfect. So the answer will be definitely option D. The next question is from definite integration. The question is saying the value of integral minus 1 to 1 x square multiplied by e raised to gif of x cube dx. Okay, so e raised to x cube definitely cannot be directly integrated over here without substitution. We have to take x cube as t, so x square dx will become the derivative. But here they have made that question again simple by introducing the gif part. How are we going to solve this out? Well, we have to split this question in two definitions. Why? Because we already know that if my x is varying between 0 to 1, definitely x cube is going to vary between the same range, 0 to 1. And if my x cube is varying between 0 to 1, its GIF will have the value as 0. And when I take the next case, when x is varying between minus 1 to 0, x cube again is going to vary between the same range minus 1 to 0, but here the GIF will be equal to minus 1. So that means since my GIF is discontinuous at 0, between minus 1 to 1, I have to split this into two definitions. Is this much clear? Perfect. So let's start writing down. So I can say that integral will be minus 1 to 0 x square, and we have just seen the GIF is minus 1, so it's e raised to minus 1 or 1 by e dx, plus I'll have the next term as 0 to 1 x square. The GIF is e raised to 0, which is nothing but 1 into dx. Clear? So quickly integrating both the parts, the first one will become x cube by 3e between minus 1 to 0, while the next one will become directly x cube by 3 between 0 to 1. And this value will become 0 minus of minus 1 divided by 3e plus 1 minus 0 by 3. Finally coming out as 1 by 3e plus 1 by 3. And if you want, you can obviously take the LCM. It's going to become e plus 1 by 3e. So this question was again from easy to moderate. I would put this question in easy category, but again that depends upon how much frequently you are well versed with the concept of GIF. So here this is the answer, and now if we check the options, we can clearly see that answer will become C. Well, the next question is very interesting. Let's say a war is going on, and here it's like a movie. The scene is when a missile is fired from a ship. The probability that it is intercepted is 1 by 3. That means it's cut off, it hasn't reached its destination. So the probability that it will get intercepted by the opposite army is 1 by 3. And the probability that missile hits the target given that it is not intercepted is 3 by 4. So if there is no obstruction, the missile is actually going towards the target, it's not cut off, the probability that it will hit the target is again not 1, it's 3 by 4. Okay, so if they are saying that 3 missiles are fired independently from the ship, thinking that if first is not going to hit, maybe second or maybe third, what is the probability that all the 3 are hitting the target? Okay, so I have to find this. So let's quickly write down what are the informations given. The information is that if the missile is intercepted is 1 by 3. That means if the missile is not intercepted, the probability will be 2 by 3, which they have not given. But this you have to understand on your own, right? So if it's intercepted, the probability is 1 by 3. Therefore, if it's not intercepted, the probability is 2 by 3. Further, it's saying that probability of missile hitting the target, given that it is not intercepted, the probability of missile hitting the target, given it's not intercepted, is given to me as 3 by 4. What they have asked, what is the probability of missile hitting the target? And that too, how many times? 3 times. So that means I have to find the probability of missile hitting the target. Clear? Okay, so these are the informations which they have given to us. So first I'll find probability of a missile hitting a target. Now guys, tell me one thing. If my missile is intercepted, its probability of hitting the target will be a big 0, right? So I can clearly say that if my missile has to hit the target, it has to be non-intercepted. So I can say that probability of missile not getting intercepted multiplied by, if my missile is not intercepted, it's going straight away to the target, what is the probability of its hitting the target at the right point? Well, that probability is probability of hitting the target given the missile is not intercepted. So when we substitute the values, we have already seen probability of not getting intercepted, probability of missile not getting intercepted is 2 by 3 multiplied by 3 by 4, which is going to come out as 1 by 2. Have you understood? If missile has to hit the target, it has to be not intercepted. So I have to multiply first by that probability. I have to write down that probability multiplied by, if the missile is not intercepted, it's going or focusing towards directly the target, it's going towards the target without any obstruction. The probability of it hitting the target is also given to me as 3 by 4. So I have to multiply further by 3 by 4. So when I do that, my probability of hitting one time is half. And how many times have they done that? 3 times, and they won't hit every time. So my overall probability of all the 3 hits is going to be 1 by 2 multiplied by 1 by 2 multiplied by 1 by 2, which is equal to 1 by 8. So it will be 1 by 8 probability that the missile is going to hit the target if it's hitting all the 3 times. That means probability is actually less, right? Okay, so this will be the final answer. And now, if we look at the options, we know that answer is going to be A. Is this clear? Perfect. So the next category is numerical answer type. There are 10 questions from which only 5 questions were required to be attempted. But as usual, I'm going to discuss all the 10 questions here with you so that you can make out on your own which questions were doable on the easier side and which were tough. So let's start with the question. The question says let A1, A2, A3 and so on be the squares such that for each n greater than equal to 1, the length of side of an equals the length of diagonal of an plus 1. Further, they are saying if the length of side of A1 is 12, smallest value of n for which area of an is less than 1. Okay, so that means they are all squares. The first square A1 is having the side length as 12. And they are saying that side of an is equal to diagonal of an plus 1. So if my side of a1 is 12, that means my an plus 1, that is my a2, will have the diagonal length as what? 12, right? So that means I can say that its side length will be 12 by root 2. Clear? This again will go for A3. So my A3 will have the diagonal length as 12 by root 2. That means my side length will be 12 by 2. So this is the pattern. Can you see the pattern? Initially the side length was 12, then it was 12 by root 2, then 12 by 2, again it will be 12 by 2 root 2 and so on. So this sequence is definitely a GP, isn't it? So to get the area of AN, what I need to find? Well, I need to find its side, right? So let's quickly write this pattern. So this is what we have observed. I have A1 with side length 12. Then I have A2 whose side length we have just found out it's going to come out as 12 by root 2 in this square. Then I have A3 whose diagonal is 12 by root 2. The side will come out as 12 by 2. And this will go on. I have to find the smallest value of n for which area of an is less than 1. So my side pattern is going to be like this. I have 12 as the first term, then I have 12 by root 2, then I have 12 by 2 and so on. This is a GP. If I have to write the nth term of this GP, you know the formula. What is nth term of GP? Well, that is A multiplied by R raised to n minus 1, right? So my A value will be 12 and my R value, which is the common ratio, will be equal to 1 by root 2 raised to n minus 1. Clear? Now I have to write its area. So I can say that area value will be equal to side square, that is 144 multiplied by 1 by root 2 raised to n minus 1 whole square, which further can be written as 144 multiplied by 1 by 2 raised to n minus 1. And this value is given to me as less than 1. That means 2 raised to n minus 1 has to be greater than 144. And what is the smallest value of n possible? Well, we know that 2 raised to 7 is nothing but 128 and 2 raised to 8 is equal to 256. That means my n minus 1 value has to be greater than or equal to 8. It can be 8, 9, 10, 11 and so on. So my smallest n, which is asked in the question, will be equal to 9. This will be the smallest value of n possible for this question. Have you understood? This was the question from GP of the chapter again sequence and series, and the answer came out to be 9. Got it? Perfect. Well, this question is saying the graph of sine and cosine intersect each other at number of points. Yes, definitely they intersect at infinite points. And between two consecutive points of intersection, the graph encloses the same area, which is also true. Suppose if we plot the graph of sine somewhat like this, right? And we also plot the graph of cos, which will be like this. So we can clearly see that they are actually enclosing some regions whose area has to be same because the regions are symmetric. This will be my one region, then I'll have this as my another region, this will be my third region, and so on. So this will also be having the same area. So I have to find area of one such region that is given to me as A. If I get the value of A, I can definitely find what is the value of A raised to 4. Clear? Okay, so coming to the first part, in this A, I know the first intersection point of sine and cos. Well, that occurs at pi by 4. And the next intersection point over here, it occurs at 5 pi by 4. So I can directly integrate sine and cos between pi by 4 to 5 pi by 4. Right? So now you can clearly see this question actually comes under very easy category. We have to just integrate to find area between the two curves which are sine and cos. And if I have my two curves, I have to write area such that it can be written as upper curve minus lower curve. So area of this shaded region will come out as upper curve, which is sine, minus lower curve, which is cos, and the limit is varying from pi by 4 to 5 pi by 4. Clear? So quickly integrating, I'm going to get A is equal to, what is integration of sine? Well, that is minus cos from again limit pi by 4 to 5 pi by 4. And what is integration of cos? Well, that is sine. So it's going to be sine again from pi by 4 to 5 pi by 4. And now what we have to do? 5 pi by 4. And now what we have to do? Just substitute the values, right? So when I do that, my A value will come out as minus, I'm taking common. I'll have cos 5 pi by 4, that is minus 1 by root 2, minus cos of pi by 4, that is 1 by root 2. Then I'll have plus sine, again I'll have minus 1 by root 2, minus 1 by root 2 again. So this value is actually going to become plus 4 times of 1 by root 2. That can be written as 2 root 2. So my A value is 2 root 2. So I can quickly say that A raised to 4 is 2 root 2 raised to 4. That is 16 into 4 equal to 64. This is the final answer and the question was on the easier side. Or you can mark it on the moderate level also. Have you understood? Perfect. So the answer will be 64. Well, moving further, this question is saying the locus of point of intersection of the lines root 3 kx plus ky minus 4 root 3 is equal to 0 and root 3x minus y minus 4 root 3k equal to 0 is a conic whose eccentricity is. So we have to find the eccentricity of conic, which will be basically locus of point, which is intersection of these two lines. So to find the locus of point of intersection, we have to eliminate k. Okay, so first we have to definitely learn how to eliminate this k. So what I'll do is, in my first equation, I'll divide the entire equation by k. So when I do that, it's going to become root 3x plus y is equal to 4 root 3 by k. I'm taking 4 root 3 on my right hand side. Similarly, in my second equation, I'm just writing it as root 3x minus y is equal to 4 root 3k. And now you can clearly see if I have to eliminate k, I'll just multiply these two equations. Isn't it? So when I multiply, it's going to become root 3x plus y multiplied by root 3x minus y is equal to 4 root 3 whole square. The final curve comes out as 3x square minus y square is equal to 4 root 3 whole square. Well, that is 48. Further can be written as x square by 16 minus y square by 48 is equal to 1. What this curve is, guys? Well, it is hyperbola. That's correct. So what we have to find is eccentricity of this standard hyperbola. I hope you remember what is the formula. Well, the formula is E is equal to root over 1 plus b square by a square, right? So it's going to be 48 by 16, which will become root over 64 by 16, which is root over 4. The final answer is 2. This will be the eccentricity of hyperbola. Have you understood? Perfect. Well, moving further, this question has given us a matrix. Obviously, question is of matrices and determinants. Matrix A is given to us as 0 minus tan theta by 2, tan theta by 2, 0. And I2 here definitely is my identity matrix of order 2. So I have I2 plus A multiplied by I2 minus A whole inverse is equal to another matrix which is A minus B, B and A. Then they have asked what is the value of 13 times of A square plus B square. Okay, so what should we do? Well, the one thing which obviously comes to our mind is, do I have to find I2 plus A, then multiply it by I2 minus A whole inverse and then compare to get the values of A and B, right? Well, we can do that. No problem in that. But trust me, guys, this question is really very simple and can be done in one straight line. Yes, you don't have to solve nothing, or I would say you don't have to solve much over here. There is no need to find I2 plus A or I2 minus A whole inverse. How is that possible? Well, let's find out. So I have my A matrix with me. Now, guys, listen very carefully. They want us to find the value of 13 times of A square plus B square. I'm going to tell you a shorter trick here, and you have to obviously understand and keep that in mind that if some questions can be done in a shorter way, your time will be left to attempt more number of questions which might be a bit lengthy, isn't it? And that will be advantageous on your side. So this question is actually done in a very shorter approach. What we have to do is, if I want to get A square plus B square, that means this matrix, let me take this as B. The determinant value of B is, the determinant value of B is nothing but A square plus B square itself, isn't it? So that means anyhow, if I can get the value of determinant of matrix B, I'll get the answer, right? Now, moving to that part, if I have my I2 plus A multiplied by I2 minus A whole inverse is equal to, let's say, B, I'm going to take determinant on both sides over here. So when I do that, can I get the value of I2 plus A determinant and I2 minus A inverse determinant? Well, this further can be written as I2 plus A determinant divided by I2 minus A determinant, and it is equal to determinant of B. Now, there again, I'm telling you two different things. First of all, what you can do is, since this is valid for all values of theta, isn't it? Because A square plus B square definitely will be independent of theta. So if this is valid for all values of theta, I can put any value of theta and get the answer, right? So that is one thing. If suppose you don't want to put any value of theta, you can take, suppose if you want to take any value of theta, you can take your theta as 0. So your A will be null matrix. If that is the case and your A is null matrix, so when you put your theta as 0, your A is going to become a null matrix. In that case, you are left with determinant of B is equal to determinant of I2 divided by determinant of I2, and that value is 1, right? That means A square plus B square will be equal to 1, and 13 times of A square plus B square value will directly come out as equal to 13. So this is another way. While if suppose you don't want to go like that, you don't want to substitute the values, we can directly find I2 plus A determinant, which is also not difficult. Well, I2 plus A is what? When you add identity with A. So when you write I2 plus A, it's going to be 1. Then you'll have minus tan theta by 2. Then you'll have tan theta by 2 and 1. Right? So when you take determinant on both sides, my determinant value of I2 plus A will be determinant of this matrix, which will be equal to 1 plus tan square theta by 2. Or if you want, you can write this as sec square theta by 2. Clear? Similarly, if you want to go about writing I2 minus A matrix, so I2 minus A will be equal to 1. Here you are going to get tan theta by 2. Here it will be minus tan theta by 2, 1. And when you take determinant both sides, this again will be equal to 1 plus tan square theta by 2, or directly can be written as equal to sec square theta by 2. What does that mean? Well, that means that if I consider my first equation, let me take this as my first equation, determinant of I2 plus A and determinant of I2 minus A is same. So that is going to get cancelled, and from 1, I can say again that determinant of B will be equal to 1. From here also, I'm going to get A square plus B square as 1. And again, the final answer will come out as 13 only, right? So there are many ways to solve this question. The smallest way, I hope you have considered when you put theta as 0. Another possible way is when we have taken the determinant both sides, right? Or if you don't want to go by this, then definitely you have to solve for I2 plus A, find I2 minus A whole inverse, multiply and get the values of A and B. Clear? Perfect. So the answer with us is 13. Well, this question says that fx is a polynomial of degree 6 in x, in which the coefficient of x raised to 6 is unity. That means coefficient of x raised to 6 is 1, right? Further, it's saying that it has extrema at x is equal to minus 1 and x is equal to 1. So there are 2 points of extrema. Now, what do you mean by extrema? Well, extrema is either maxima or minima. And the condition which we apply is what? You are right. Well, we have to apply f dash x equal to 0, and f dash x will be 0 at 2 points, which are minus 1 and 1, right? Further, they have given us one more information. Limit x is approaching to 0, fx by x cube, well, that is 1. Then, what is the value of 5 multiplied by f of 2? Now, guys, if you want to find this value, I have to definitely get the value of f of 2. Or you have to get the value of f of 2. And to get the value of f of 2, you have to find the function fx. Clear? So that means I have to anyhow solve for fx. Now, if I consider, suppose my fx, I can say that fx is x raised to 6 because its coefficient is 1. Plus, I'll have, let's say, ax raised to 5 plus bx raised to 4 plus cx cube plus dx square plus ex plus f. Now, here I have so many variables whose values I have to find out, but I have 3 relations only. I have f dash minus 1 as 0. That is going to give me one condition. F dash 1 as 0 is going to give me the second condition, and limit is going to give me the third condition. So, first of all, let's work about what this limit part is saying. So, the limit is saying that fx by x cube, when I put limit x is approaching to 0, this value is given to me as 1. What do you mean by this? Well, it's very simple. If suppose I divide this fx by x cube, you know that I will have terms like x cube plus ax square plus bx plus c. Then I'll have plus d by x plus e by x square plus f by x cube, right? And supposedly, if my x is approaching to 0, they are saying that limit should be 1. So that means my x cube, ax square, bx part will be 0. I will be left with, first of all, c. So c definitely should be equal to 1. Furthermore, I'll have these 3 terms left. I'll have d by x, e by x square, f by x cube. So if d, e, f are non-zero, this limit when x is approaching to 0 will go to infinity, right? But what they have mentioned, that limit is 1. What does that mean? That means that d, e, f have to be 0. That's correct. These 3 numbers should be 0. Then only you will get a finite limit. Clear? So that means my final fx can be written as x raised to 6 plus ax raised to 5 plus bx raised to 4 plus x cube. That's it. We cannot go beyond x cube. Is this part clear? Perfect. And guys, let me tell you one more thing. The same question, almost I will say maybe some data might have changed, but a question was there in previous JEE exam also. It was also based along the same line. They have given one information about limit and some information about the extrema. So that again emphasizes that you have to practice the past year papers also along with this Feb attempt if you are targeting March, May or April exam, or suppose if you're targeting for next year, then again you have to solve the past year papers, which are clearly very important. Understood? Perfect. So we have got fx, right? Now I have to apply these conditions of extrema. So I have my fx as x raised to 6 plus ax raised to 5 plus bx raised to 4 plus x cube. And since the extrema is at -1 and 1, that means my derivative should be 0. So I will have f dash of x first of all. Let me find this out. So it's going to be 6x raised to 5 plus 5ax raised to 4 plus 4bx cube plus 3x square. And when I put the condition that when my x is -1 or 1, this value is 0, I will get two equations. And from those two, I'll get the values of a and b, right? So guys, start solving with me and let's find out quickly what the values of a and b come. So when I put my f dash 1 as 0, I'm going to get 6 plus 5a plus 4b plus 3 is equal to 0. Similarly, when I put f dash of -1 as 0, it's going to come out as -6 plus 5a minus 4b plus 3 again is 0. And here when I add these two conditions, definitely my b is going to get cancelled out. And I'm going to get 10a plus 6 is equal to 0. So from here, a value is coming out as -3/5. Clear? Now, we can find value of b by substituting in any equation. So let's say I'm substituting my value of a in this. So it's going to give me 6 plus 5a. Now, in place of a, I can directly put -3/5 plus 4b plus 3 is equal to 0. From here, b value comes out as -3/2. So now I have a with me, I have b with me. I have to just find f of 2, right? And then multiply by 5 to get the final answer. Okay, so when we work upon that, I'm going to get my f of x as x raised to 6 minus 3/5 x raised to 5 minus 3/2 x raised to 4 plus x cube, right? And when I actually find the value of 5 times of f of 2, it's going to become 5 times of, I'll have 2 raised to 6, then I'll have minus of 3/5, 2 raised to 5, then I'll have minus of 3/2, 2 raised to 4 plus 2 cube. This obviously can be solved in very easy way. So it's going to become 5 times of 2 raised to 6 minus 3 times of 2 raised to 5 minus 3 times of 2 cube plus 2 cube, which further can be written as 32 multiplied by 7 minus 10 into 2 cube. And when you solve this out, the final answer comes out as 144. So this will be the final answer, which will be the value of 5 times f of 2. Is this clear? Have you understood how you have to use this limit information, which was a new thing, right? Perfect. So the answer is 144. Well, this question says the number of points. We have to find the number of points at which the function fx is equal to mod of 2x plus 1 minus 3 times mod of x plus 2 plus mod of x square plus x minus 2 is not differentiable. So here I have to check the derivability of this function, right? Okay, and they have given me the mod. That means we know that if I have a single mod, suppose if I talk about mod of x plus 1, it is non-differentiable at x is equal to -1/2 because that is the critical point. So that means my critical points will create a problem, and at those points only I have to check the derivability or the differentiability, right? So when I write this, it's going to become twice of x plus 1 minus 3 times of x plus 2. And what are the factors of this quadratic? Well, the quadratic factors are x plus 2 multiplied by x minus 1. So it's going to become modulus of x plus 2 multiplied by modulus of x minus 1. This is equal to f of x. Clear? So that means how many critical points are coming in total? Well, I have 3 critical points. Minus half is one of them. Then I have minus 2 and then I have 1. So these are my 3 critical points at which I have to check the differentiability. Clear? Perfect. So we have seen that we have to check the differentiability at minus half, minus 2 and 1. Okay, now guys, listen very carefully. When my x is equal to minus half, I have this as my non-differentiable function because critical point is minus half for this. But the rest of the two modulus part will be differentiable because they don't have minus half there as their critical point, right? So if minus half is not the critical point, I have a linear, I have a quadratic, which are definitely differentiable at x is equal to minus 1 by 2. So that means we have already read the property that non-differentiable plus differentiable is going to give me non-differentiable. So minus half is one point at which the function will be non-differentiable. Clear? Similarly, if I check at x is equal to 1, when I talk about x is equal to 1, what is going to happen? Well, at x is equal to 1, 2x plus 1 will be differentiable because x is equal to 1 is not its critical point. Similarly, 3 times of x plus 2 with a minus sign, minus 3 times of x plus 2 mod. So mod of x plus 2 again will be differentiable. But this quadratic will have 1 as its critical point and definitely it will be non-differentiable. We can see that very quickly. If I have, let us say, the graph of quadratic, we know the quadratic has factors x plus 2 and x minus 1. So the roots will be minus 2 and 1, somewhat like this, right? And when I plot the graph of its modulus, what is going to happen is I have a graph like this, isn't it? So that means definitely it will be non-differentiable at x is equal to 1. Clear? So I have this quadratic as non-differentiable at x is equal to 1. Again leading to the same condition that non-differentiable plus differentiable is going to give me what? Non-differentiable, that's correct. So that means 1 is also a point at which this entire function will be non-differentiable. Have you understood? We haven't solved for anything. We have just seen by the property of derivability when some multiple functions are involved. Clear? Okay. Now coming to the point minus 2. So what is going to happen when I take x is equal to minus 2? Well, when I have x is equal to minus 2, I have my first function again as differentiable, but my second function and third function are non-differentiable. So whenever I have a non-differentiable function plus or minus another non-differentiable function, it is going to give me any, either derivable or non-derivable. It can be either differentiable or non-differentiable. Correct? Understood? Perfect. So what should I do for that? Well, for this, we'll just try to check what is going to happen when x is approaching to, let us say, minus 2 plus, and when x is approaching to minus 2 minus. That is how we check for derivability, right? If my left-hand derivative and right-hand derivative comes same, that means the function will be differentiable. If they are different, it's going to be non-differentiable. Clear? Okay, so perfect. We are going to do that. So when I actually write minus 2 plus, what do you mean by minus 2 plus? Minus 2 plus means that x is slightly greater than minus 2, right? So when I have x greater than minus 2, my fx, the first modulus definitely is going to open by minus sign, right? So I have f is equal to minus 2x minus 1. Similarly, when I take x slightly greater than minus 2, my second mod will become positive. So the value is going to open by plus sign. So it will remain as it is. So it's minus 3x minus 6. And when I look at the quadratic, I have two terms like x plus 2 and x minus 1. So when I take my case when x is greater than minus 2, I can say that this part definitely is going to be negative, right? Perfect. So this is going to open again by a minus sign. So when I find my f dash, it's going to become minus 2 minus 3, minus 2x, minus 1. So the value will come out as minus 2x minus 6. And here when I put my x as minus 2 plus, to find the limiting value, I'll get the value as minus 2. Perfect? Understood? Very well. Now when I talk about x is approaching to minus 2 minus, that means I'll have the case when x is slightly less than minus 2. Clear? So when my x is less than minus 2, my first mod again will open by a minus sign. So it's going to become minus 2x minus 1. What about the second mod? Well, mod of x plus 2, if I look at x plus 2, this quantity will be negative. So mod is going to open by minus sign. So it's going to become plus 3x plus 6. Similarly, the quadratic part, when I have my x value as slightly less than minus 2, my x plus 2 will be negative, x minus 1 again will be negative. So entire quantity will be positive. So that means my mod is going to open by plus sign. Clear? So I'll have the next term as x square plus x minus 2. Now what? Well, now I'll try to find my f dash. So it's going to become minus 2 plus 3 plus 2x plus 1. This value is coming out as 2x plus 2. And when I find the value of f dash minus 2 minus, the limiting value of this value is actually coming out again as minus 2. That means I have my function which is differentiable at x is equal to minus 2. And if it's differentiable at x is equal to minus 2, I can clearly say that there will be 2 points which are minus half and 1, at which the function will not be differentiable. Understood, guys? Perfect. So the answer will be 2. Well, the next question is, if the system of these equations, they have given us 3 equations, has infinitely many solutions, then what is the value of k? Now, guys, it seems to me this is a question from matrices and determinants, right? They have given a system of equations. Suppose if I solve this by determinant, what I have to do? Well, for infinite solutions, we remember the condition delta 1, delta 2, delta 3, all 4 must be equal to 0, right? You can also go by matrices. But I'll tell you one more way to solve this. You might not be knowing this way, or it might not strike to you when you solve this question or when you see this question once. What is that method? Well, we are going to solve this question using 3D geometry. Yes, we are considering these 3 as 3 different planes. I hope you remember what is the equation of plane, right? So let me take these as my 3 planes. So if my 3 planes give me infinitely many solutions, there are 2 cases possible. Either I'll have coincident planes, one above the other. But for that, my planes have to be definitely parallel. So you can clearly see that my second and third equation, if I consider these 2 as planes, they are not at all parallel, right? Their normal is in different directions. So that means I won't have the condition of coincident planes. Clear? Okay. So if my planes are not coincident, then how do we get infinitely many solutions? Well, that comes when all the 3 planes pass through a single line of intersection. Yes, let's consider a figure somewhat like this. I have a plane like this, then I have another plane passing through this. It's like a book, basically. So the the corner of the book or the end of the book actually has how many pages tied to it, right? So all the pages, they pass through one single line. So that means if you consider those pages as different planes, all those planes will have one common line passing through it. And on line, how many solutions are there? Infinite. That's correct. So I'm talking about the case when these 3 planes are actually passing through this single line of intersection. And when I have this single line of intersection, obviously I'll have infinitely many solutions. Clear? So if all the 3 planes are passing through a single line of intersection, what can we use? Well, we can use family of planes. That's right. That is what we are going to use here. So let me take the equation of planes as P1, P2 and P3. So I can definitely say that my P3, since it is passing through the line of intersection of P1 and P2, as we have just seen, can be written as P1 plus lambda P2, right? And if I substitute the values of P3, P1 and P2, or let's say the equations, I'm going to get a relation like this. I'll combine the x coefficient, y coefficient, z coefficient and the constant term. Clear? Now what? Well, now we'll just compare the coefficients on both the sides. So when I compare the coefficients, I have to obviously write the ratio. So I'm going to get k divided by 1 plus 3 lambda. This is the coefficient of x is equal to coefficient of y. When I write its ratio, it's 1 upon 1 minus lambda. For z, it's 2 upon 2 minus lambda. And for constant, it's minus 1 upon 3 by 2 minus 2 lambda. Now here you can see one thing very clearly, that these two are actually same. Both are written as 1 upon 1 minus lambda, right? So that means I'll equate this and this to first get the value of lambda and then I'll get the value of k. As simple as that. So when I do that, I'm going to get 1 upon 1 minus lambda is equal to minus 1 upon 3 by 2 minus 2 lambda. When I cross multiply, I'm going to get 3 by 2 minus 2 lambda is equal to lambda minus 1. So from here, 5 by 2 is equal to 3 lambda. Lambda value comes out as 5 by 6. And if my lambda value is 5 by 6, that means I can now get the value of k just by substituting, right? So I'm substituting the value of lambda here and here. So I'm going to get k divided by 1 plus 3 lambda is equal to 1 upon 1 minus lambda. And when I actually find the value of k, it's coming out as 1 plus 3 times of, now I'll substitute the value of lambda. So it's 3 times of 5 by 6 divided by 1 minus 5 by 6. And here when you actually take the LCM, it's going to become k is equal to 21. It's going to become the final answer as k is equal to 21. This will be the final answer. They have told us to find the value of k. And you can clearly see this approach is actually not at all lengthy. It's actually done in a few steps. You have to just find lambda and then find the value of k. While in determinants, we have to solve all the 4 determinants to find the value of k. And similarly, some conditions have to be applied in matrices also. So what I can say here is that the approach which we have applied is the shortest approach, as you can clearly make out, isn't it? So the final answer with us will be 21. Well, the next question is from vectors, and guys, trust me, it's a very interesting question. Let's read the question first. The question is saying I have my A vector, I have my B vector and C vector. If R is a vector such that R cross A is equal to C cross A and R dot B is 0, what is the value of R dot A? Now they have given us some information. So the first thing which will come in our mind is, maybe I have to find R vector, right? If I get R vector, I'll definitely get R dot A. And to find our R vector, what do we generally do? Well, we'll assume R as xi cap plus yj cap plus zk cap. This is what I have seen students mainly approaching towards. But hold on, guys. Don't go by that method. I'll tell you a smaller and a shorter trick for this question. Okay, so these are the informations which are given to us. Now, what I can do is, I have this condition R cross A is equal to C cross A, which is pretty important. How? When I bring actually C cross A to this side, I can obviously write that R minus C cross A is 0. Isn't it? And from here, we'll actually derive one more thing. If I have two vectors whose cross is 0, when does that happen? Well, if the vectors are parallel, definitely their cross will be 0, right? And what is the condition for vectors to be collinear or parallel? One vector should be some scalar times of another vector. This you have learned, isn't it? So from here, we can say that R minus C should be equal to lambda A. Let's assume lambda is the scalar. So that means to get my R, I have to just get the value of lambda. Clear? So from here, I can say that R is equal to lambda A plus C. Understood? Now to get the value of lambda, we have one more information with us. What is that? R dot B is 0. So when I take its dot with B and put it equal to 0, it's going to become R dot B, which is 0, is equal to lambda times of A dot B plus C dot B. Now we already have A, B and C. So quickly finding the values of A dot B and C dot B, it's going to become 0 is equal to lambda times of my A dot B value will be 1 minus 2, while my C dot B value will become 1 plus 1. So from here I can say that my lambda value is equal to 2. Clear? Now if my lambda is 2, I have definitely got my R vector as 2A plus C by this condition, right? So if my R is with me, I can obviously find R dot A. So to get R dot A, I'll take its dot with A. So when I write that, I'll get R dot A is equal to twice of A dot A plus C dot A, which is again very simple to find. A dot A is nothing but modulus of A whole square. So I have A as I cap plus 2J cap minus K cap. You know its modulus square is going to be 1 plus 4 plus 1, that is 6. So it's going to become twice of 6 plus what is C dot A? So quickly finding C dot A over here, it's going to become 1 minus 2 plus 1. What is this value equal to? 0. That's right. So that means my final answer or the value of R dot A is coming out as 12. So in first attempt, you might leave this question because you'll think that I have to find R vector, that means X, Y and Z. But trust me that this question was not that much difficult also. I'll put this in moderate category. Solution was not at all lengthy. What you have to remember or what you have to actually look out for is R cross A is equal to C cross A. This was the main point over here. If you would have thought that R minus C cross A is equal to 0, I can write this as that. And further, R minus C can be written as lambda A. Bingo, your half of the job was already done. You just have to find the value of lambda and finally the answer. Have you understood? So from now on, I hope if you haven't got the answer till now, you'll remember this approach. Clear? Perfect. So the answer finally is 12. Well, the next question is from matrices and determinants, and I would like to put this question in moderate category. It was not that easy also. You have to observe few things over here. So let's begin with the question. A matrix is given to me as a symmetric one. It's x, y, z, y, zx and zxy. X, y, z are real numbers. They have given one condition, x plus y plus z is greater than 0. That has to be used. Similarly, their product is equal to 2. Further, they have said that A square is an identity matrix. What is the value of x cube plus y cube plus z cube? Now, again, some of you might have thought that if my A square is identity, I might have to solve for A square. I have to multiply A into A, then I'll get A square and equate it to identity matrix. Some elements will be 1, another will be 0. That might get me the value of x, y and z. And obviously, when I actually say this, you also know along with me that process will be very lengthy, right? You might want to leave the question. But again, what I do, I make the process very simple for you. I will actually not find A square over here, but I'll use this information in some another way. What I can say from here is that if my A square is identity matrix, when I take determinant on both sides, I know my determinant of A square value will be 1 because identity matrix has determinant 1. I hope you understand what is I3. I3 is a matrix, identity matrix of order 3. Clear? So that means my determinant of A will have two values, either 1 or minus 1. Understood? Perfect. So we have to use this information that determinant of A is either plus 1 or minus 1. Clear? Now, how am I going to use this? Well, if I have A, obviously I can find its determinant value. So the determinant value of A is going to come out as, when you expand, or you might remember this determinant, it's very pretty basic one of the standards which have been taught in determinants. So it's 3xyz minus x cube plus y cube plus z cube. Okay, so that means I already have x, y, z. I'll substitute it here. I'll get the value of x cube, y cube, z cube. But you have to remember, you have to equate it to one of these two, either 1 or minus 1. And then only you'll get one unique value. Now comes the question, how should I decide whether it will be 1 or minus 1? Well, for that, we'll use this information that x plus y plus z is greater than 0. So when my x plus y plus z is greater than 0, how will I use this? So for that, my determinant of A can also be written as minus of x plus y plus z multiplied by x square plus y square plus z square minus xy minus zx minus zy. How? This is the formula, guys, the pretty basic fundamental identity which you must have read, I'm very sure about. A cube plus B cube plus C cube minus 3ABC plus I'll get a term like this. A plus B plus C multiplied by A square plus B square plus C square minus AB minus BC minus CA. You have to remember the identities. It's pretty important. Okay, so that means these two are same. And this term x square plus y square plus z square minus xy minus yx minus zx is always greater than 0. Why this term is greater than 0? Because it's actually sum of three perfect squares. Let me tell you this also. It's half of x minus y square plus y minus z square plus z minus x whole square. So this quantity is greater than 0. Understood? Perfect. So that means I can say from here that my determinant of A will be negative because x, y, z again is given to me as greater than 0, a positive quantity. So if my determinant of A is negative, it implies that my determinant of A definitely should be equal to minus 1. Right? Now, if I substitute this in this condition, I'm going to get 3xyz minus x cube plus y cube plus z cube is equal to minus 1. And from here, x cube plus y cube plus z cube will come out as 3 times of xyz. The value I'm substituting for xyz is 2. So it's 3 times of 2 plus 1, which is equal to 7. So this will become the answer for the question. Have you understood, guys? You don't have to solve for A square. We'll find the determinant over here. Clear? Perfect. So the answer for the question is 7. This question is from permutation and combination, and that too on the easier side. Let's first read the question. The question is saying, what are the total number of numbers which are lying between 100 and 1000? That means I have to find a 3-digit number, first of all. That can be found with the digits 1, 2, 3, 4, 5. If repetition is not allowed and the numbers are divisible by either 3 or 5. So that means I have A or B kind of thing here. So what is my A or B, or let's say A union B? When I talk about sets, it's basically number of elements in A plus number of elements in B minus number of elements in A intersection B. Right? These are the number of elements in A union B. Or I can say that number of numbers which are divisible by 3 or 5 will be equal to number of numbers divisible by 3 or divisible by 5. I have to put a plus minus the numbers which are divisible by 3 and 5 both. 3 and 5 both, that means they will definitely be divisible by 15. Clear? So that means I have to find all the numbers which are divisible by 3, then all the numbers which are divisible by 5, and subtract the numbers which are divisible by both 3 and 5. Is this much clear? Perfect. Let's begin with the solution. I have my digits 1, 2, 3, 4 and 5 with me. I know repetition is not allowed. So first of all, I'll find all the digits which are divisible by 3. So what is the divisibility condition for 3, guys? Well, the sum of numbers must be divisible by 3, right? So first of all, let's find sum of all these 5 numbers. So the sum actually is coming out as 1 plus 2 plus 3 plus 4 plus 5, well, that value is 15, which is divisible by 3. But I cannot take all the 5 numbers. I have to take only 3. That means I have to exclude 2 numbers, right? And which numbers should I exclude? Well, their sum again should be divisible by 3, isn't it? Such that the remaining sum again is divisible by 3. Understood? So I have to find 2 such numbers whose sum is divisible by 3. So here you can clearly write down what cases will be having. I can exclude 1 and 2 because their sum is divisible by 3. It's 3. Then I can exclude 5 and 1. I can exclude 2 and 4. I can exclude 4 and 5. So there will be 4 cases where the sum will be divisible by 3. Understood? So when I want to write the numbers for this, if suppose I exclude 1 and 2, I'll have 3 places and 3 numbers, 3, 4, 5 to be filled. So you know 3 numbers, 3, 4, 5, if I have to arrange in 3 places, number of ways are 3 factorial. Similarly, if I have 5 and 1, I'll have again 3 numbers, including the numbers 2, 3 and 4. Again, their arrangement is 3 factorial. So that means for rest of the 2 cases, again it will be the same. 3 factorial numbers will be formed for each. So that means my total numbers here will come out as 4 multiplied by 3 factorial, that is 24. Clear? Perfect. This is divisible by 3 part. Now I have to find the numbers which are divisible by 5. So if the numbers are divisible by 5, the case is really very simple. The last digit definitely should be 5. So that means I have 2 digits left and I have 4 numbers to place. So I can say that my first number will have 4 options multiplied by my second place is going to have 3 options. Total 12 digits will be there which are divisible by 5. Now I have to find the digits which are divisible by both 3 and 5, or you can say divisible by 15. So if I have divisibility for 5, I can write very clearly that my last digit should be 5. So that means these two definitely should be placed such that the entire sum is divisible by 3. So how many cases are there? Well, we can quickly look upon that also. I can have my cases, this is already 5, right? So that means my sum of numbers cannot be 6. So the next place available is 9. So if my sum is 9, I should have 1 and 3 placed over here, right? Such that the sum is equal to 9. So 1 and 3 can be arranged in how many ways? Well, that can be done in 2 factorial ways. And I can have more cases. Suppose again my last digit is 5. My sum after 9 is 12. Again divisible by what? Divisible by 3, right? So that means if I have to make the entire sum as 12, these two numbers should be 3 and 4 because their sum will be 7 plus 5 again is going to be 12. Again, these can be arranged in 2 factorial ways. Now, think about, can I get the sum higher than 12? Well, I cannot get it as 15 because 5 is already placed on the last place. I cannot get the sum of these two places as 10. It is not possible, right? So that means these are the only 2 cases which will be, so the number is divisible by 15, right? So that means I'll have 4 cases for this. 2 factorial plus 2 factorial is 4. So when I have to find the number which are divisible by either 3 or 5, I can use A union B formula, which we have just seen. So it will be 24 plus 12 minus 4, which is going to come out as 24 plus 8, that is equal to 32. So these are the total numbers which will be divisible by either 3 or 5. Have you understood? A simple question, right? Perfect. So the answer will become 32.